In the first exercise that we're working on, we were going to measure the rate of flow of air going through a pump. Now, these pumps, very frequently, we take a look at these pumps. Sometimes they'll have a little rotometer built into them, a little gauge that'll tell you how fast they're moving air or pulling air. Not all of them have that. And when they do have it, they're not terribly reliable either. At best, you can use that to set the pump volume for, say, 1 liter per minute, 2 liter per minute. But it's not reliable enough for you to depend on in terms of determining how much air you've sampled after it's run for an hour or 2 or 3 or 8 hours and so on. So we want a more accurate way to judge how fast air is moving through this pump. So our first technique is going to be use a very accurate version of a calibration device called a bubble burette. And in fact, it's just an inverted burette like you would see in any chemistry class. It's very large. It's 1 liter of air, 1,000 milliliters or cc's, and 1 liter of air can be pulled through here. Okay, and we're going to connect that to a trap, and then, which is just simply a burette, a flask, like a Erlenmeyer flask, so that the bubbles can get captured and not drawn into the pump. And then from there, we're going to pull air from that trap into our pump. So it's really just going from, and in fact, we didn't have a trap available. So literally, we're just pulling air through this burette and through the pump. Now we can bring a little cup up to the bottom of this burette as this pump is pumping, and we can form a bubble that rises through the burette at a given rate. And that rate's determined by how fast this pump is pulling air. And this is very accurate. It's basically a frictionless piston that moves with the air as the air moves. And it's a very accurate way for us to tell what volume air is moving through this over a period of time. The reason why it's very accurate is because these laboratory burettes are manufactured to very high standards, and it's certainly better than less than 1% error in terms of the actual volume. Probably a lot better. Probably the biggest problem with this technique is that is how good you are at using a stopwatch to time when the bubble goes past the first marker and then again past the 1,000 milliliter marker, so you know a liter of air has been drawn through that in that period of time. So pumps running. We don't happen to have a trap on ours. It's going to draw a bubble up through here, and we're going to time how long it takes the bubble to go 1 liter, go through the length of this burette. Okay, and then we're going to go over to our Excel spreadsheet. Now I've put in numbers here simulating this. The pump is on. We set the pump on wherever we're going to set it. Okay, and the reason why you see 3 readings here is because we're introducing certain inaccuracies, such as how good we are with a stopwatch. We're not going to want to take just 1 reading. We're going to want to take at least 3 readings and average them to determine what the real flow rate is through this device. So I've put in here that we got it set on low. Pump is running continuously through this whole process. I start the first bubble up. First bubble goes up. It takes 58 seconds for that bubble to go the length of 1 liter in that burette. So I do it again. Second bubble takes 59 seconds. Third bubble takes 57 seconds, right? This variability probably has more to do with my timing than it does with the actual pump itself. So now we have to determine, well, what flow rate does that represent? I know if it takes 60 seconds for a liter of air to go through the burette, 60 seconds is a minute, and it's 1 liter, so it's 1 liter per minute. So since it went a little bit faster, I know right away that it's flowing at a little bit faster than 1 liter per minute. Very simple formula for figuring out the actual flow rate. It's 60 seconds per minute divided by the number of seconds it takes to get 1 liter of flow through here. So in other words, in this case, it would be 60 divided by 58. So I'm going to do this calculation right here in Excel. I can actually do it by setting up a formula. Equals 60 seconds divided by the amount of time it took to pull 1 liter of air through the burette. So the flow rate was 1.03 liters per minute. Okay, and I'm going to copy that formula down. And for 59 seconds, it comes out to 1.01. For 57 seconds, it comes out to 1.05. It will be very valuable for you guys to learn to improve your skills in Excel, because it's a great tool for doing calculations like this. You can see that if you look up here, 60 divided by C11, 60 divided by C12, I was able to, by grabbing that corner, and pulling it down, or highlighting and going up to the top and saying fill down, I was able to get it to copy that formula down to each of the other two cells, so I didn't have to recalculate it. Well, now I want the average of these. So I'm going to type in here equals, whoops, I'm going to type in here equal sign to let it know I'm about to put in a function, average. Excel has a function for average, parentheses, and I'm going to tell it to find the average of the three numbers between cell D10 and D12, my three values. Okay, and in fact, it turns out that the average flow rate is 1.03468, so on and so forth. Now I can round that. Usually it's best to round at the very end. In other words, if you round now and I call it 1.03, and then I run the pump for 100 minutes, well then I think that I would have sent 100.3 liters of air through my device, right? Well, in fact, what I really was, I'm missing an extra 40 cc's that would have been there if I hadn't rounded this off, right? So it's best to round at the very end rather than in an intermediary calculation. If you're uncomfortable with this, with viewing them this way, you can always just highlight them, say format cells, and tell it you only want to see this, for instance, to, let's say, for argument's sake, I'm going to go into numbers. Let's say I only want to see this number to 3 decimal places. That would be down to the CC, like so. Okay, now keep in mind that the actual value is still in here. It's just rounded off. Excel just rounds it off in appearance, so it's still there for you to do your calculation. So for instance, if I say equals this number times 100, notice I get much better resolution than if I would have rounded this number just by clipping off erasing the numbers at the end there. Okay, so that's how we're going to do that. Now we know that this pump as set up here, this pump has 1.035 liters per minute, or 1,035 cc's per minute flowing through the pump. That's our first exercise, is to use a bubble burette to find the rate at which air is flowing through our pump, okay, so that we can use it effectively. Okay, next video, we're going to talk about using a rotometer. And in order to use a rotometer, we need to calibrate it first so that we know it's accurate.